using a calculator that like does the algebra for you. Let's
Yeah, it's really hard. It's really hard. I had a lot of trouble with the homework. I got like a 70 on it.
let's look at it. And you know what I didn't do is I didn't start sharing my screen. If you don't get it done today, realize you can still work on it. And if you work on it tomorrow, if you start the whole thing tomorrow, what it'll be is the best you can get is a 97 instead of 100. So don't like feel like that due time is drop dead.
Well, on that one homework that I didn't finish because I couldn't get into like my math lab, the best I could get was a 91.
Well, I'll tell you what, if it was a problem with you not getting into the My Math Lab, and I apologize, I thought I had said this before.
No, you did. I just
beyond your control, send me an email and I'll give you the points back.
Right.
And what happens is you lose 2.5 points for every day late. So if you get it done by today, you get 100. By tomorrow, you get a 97.5. By Friday, you get a 95. And it just goes down a little bit every day because I wanted to incentivize getting it done on time. But I'm gonna stop sharing my screen for a minute. I want to look at everybody. How many people need extra time on this one?
I do. I'm kind of confused on it.
I do too.
Definitely would say your time would be nice.
Okay, so what I'm gonna do is after my last class today, I will go through and have that one till Friday. If anybody already went through and worked hard to get it done and get 100 on it, by the end of the day, you'll get a little bit of extra credit for having it done on time, but if you need extra time, you won't be penalized. How's that sound?
Yeah, I already finished it.
So if you already finished it, because I want to give you a reward for already finishing it, if you already finished it and you got them all right, I'll give you extra credit. If you didn't get them all right, you can use the extra time to go back and fix the ones that you still need to fix. Do you know what I'm saying?
Yeah.
Okay.
So
then,
it's due till Friday?
It'll be due, yeah.
Okay.
Okay.
Just so you know,
Go ahead.
Sarah's trying to get in, but
what?
It's not letting her in the call.
yeah, she can't get in.
Okay, tell her to try cutting and pasting. Other than that, I apologize. I'm not in charge of Zoom, but I don't think it's a problem with the link because everybody else is here.
She said it was their internet because of the storm.
Yeah, the storm.
Okay, tell her that we're recording class and it'll be there for her after. All right? Otherwise, if it's that her Zoom's not working, you know, if any of you can like talk to her through your phone, you know, like hold it up so she can see, you know, that would be nice too. I have 3 things on the agenda for today, and a large portion of them are going to be determined by you folks. The first thing that I want to do is go over any homework problems that anybody has problems with. And so does anybody want to look at any homework problems?
Can we do number 17?
On P6?
Yeah.
Sure. After that, I want to go through a problem set because the problem set is a practice for the test. And I'm just thinking while I'm waiting for that to come in, I do have some important things that I want everybody to see. Can everybody see the screen that I'm sharing? I'm sorry, it's properly handwritten. Exam 1 is in my labs. It needs to be done by noon on the 4th, which is Sunday. Submit pictures of your work. The test is in my labs. Submit pictures of your work in Blackboard. They need to be neat, as in legible. They need to be numbered. I will look at the work for partial credit. The test is timed. Please submit your work in Blackboard within a half an hour of finishing the test. You can only take the test once. You can only submit in Blackboard once. Friday, there is no class. Problem set 1 is the practice test. That's due by midnight on Friday. Homework 1.1, we're going to hopefully have a little bit of time to do a little bit of introduction into that. It's on graphing. Hopefully everybody remembers how to plot points and the like. That one will be due on the 7th. And then as I was typing this in, I got an email from a math organization talking about the mathematics of elections. And I thought, oh my heavens, I haven't asked you guys if you're registered to vote. And after watching that interesting debate last night, it's kind of on my mind. So whichever side of the line you fall on, that's up to you. But if you are old enough and you are a citizen, you should register to vote and vote. It's your civic responsibility. I know a lot of people like bemoan the whole thing and say it's not worth the effort. In my mind, if you don't vote, you have no right to complain about anything. So, but
I can turn 18 3 days after the vote election day.
That happened to me last year. That happened to me last year. It was horrible.
You can, if you will be 18 in time, you can register online till I think midnight on the 9th. I'm not sure about that midnight thing, but you know, you can register online through the 9th. You can go to the Board of Elections and register in person through the 9th. Or if you're doing a mail-in application, it needs to be postmarked by the 9th. If you're going to do the pencil and paper mail-in or drop it off at your Board of Elections if you're worried about the mail. I do believe that they have voter registration forms in the student life office at the college. So if you're on campus, you can pick one up there. So that having been said, but just remember, no class Friday, and that test must be done by noon on Sunday. Okay, now I want to go back to look at that homework. And what question were we looking at? I knew it was one of them, but I got distracted. Somebody had asked for a specific question. Was it 17? Okay.
Professor?
Yeah?
Canyon can't get in. Like it keeps booting him out, said, and he can't he can't stay in the chat in the Zoom. I won't let him stay in the Zoom. He keeps getting logged out of it.
Who is that?
Cannon?
Tell him to make sure that he checks the
It could be internet, but it's
yeah. Tell him to keep trying. If he can't get in, this is going to be recorded. And because I know he's trying, I won't hold it against him attendance-wise.
okay. Yeah.
All right. Somebody emailed me this one. So what we've got here is a
That was me.
That was you? Did you get my response or not yet?
I did. I haven't opened it yet, though. I haven't had time.
Okay. So with this one, we have 2 over x plus 3 over y over 3x plus 2y. If we want to know what to include, we can't have a 0 in the denominator, so x cannot equal 0. Y cannot equal 0. And the other thing, this denominator of the whole thing, we know that 3x plus 2y cannot equal 0. And so looking at the choices that they have, let's solve that for x, gives me 3x cannot equal 2y. So I'm sorry, I've got to pull up the eraser. So solving that, we get that x, I'm sorry, that's negative 2y. X cannot equal negative 2y over 3. And so y cannot equal 0, x cannot equal 0, x cannot equal negative 2y over 3. Now to get the fractions out of the fraction, the common denominator of the fractions within the fraction is xy. And so I'm going to multiply both numerator and denominator by xy. Distributing in the numerator, when I multiply xy times 2 over x, I'll have 2y. When I multiply xy times 3 over y, I'll have 3x. And I'm going to leave that denominator factored for just a minute. Xy times 3x plus 2y. With me so far? And now, as I look at that fraction, there's that common factor of 3x plus 2y.
So,
My final answer would be 1 over xy.
so what did you multiply by the numerator and the denominator again?
I'm looking at, do you see how the way this fraction is written, I have 3 fractions within it. One has a denominator of x, one has a denominator of y, and one has a denominator of 1.
Yeah.
So between those 3 fractions, the lowest common denominator, I need a factor of x, I need a factor of y, and I need a factor of 1. So that common denominator is xy. So what I'm multiplying them both by is xy. In the numerator, I'm going to distribute. And with this one, I'm leaving that denominator factored.
Can you go over 16?
Yeah. Before I go over 16, is everybody all right with 17?
Can you hold on for a second?
Sure.
Thank you.
Let me know when we can backtrack and look at 16. I think what makes this one a little bit different is when you look at that denominator 3x plus 2y equaling 0, you get an expression for x in terms of y, and not just a single value.
You can switch it if you need to. Thank you.
Somebody's got background noise. Can you mute it, please? Thank you. Okay. Can I clear it yet?
I'm good, yeah.
Yeah.
Okay. So then 16? Okay,
Yeah,
16, we've got a complex fraction. We've got 6 plus 1 over x over 5 minus 1 over x. Well, I know that the denominator can't be 0, so x cannot equal 0. But also this big denominator can't be 0. So 5 minus 1 over x can't equal 0, which would give me 5 equals 1 over x, which would give me cross multiplying 5x equals 1 and dividing x equals 1/5. So x cannot equal 0, and x can also not equal 1/5.
Okay.
Now, as I look at this, the fractions within the fraction each have a denominator of x. So I'm going to multiply both numerator and denominator by x. Distributing in the numerator, x times 6 is 6x. X times 1 over x is 1. In the denominator, x times 5 is 5x. X times 1 over x is 1. And so this is my simplified, and I have to exclude both 0 and 1/5. Because this denominator can't be 0, this denominator can't be 0, and the entire denominator also cannot be 0.
Okay.
Okay, better?
Yeah.
Thank you. Yeah, I have trouble with the values that aren't in the domain, so that's always good to know how to do those.
Yeah, when you're looking for what's in the domain, what you're always going to do is set every denominator equal to 0 and solve that resulting equation. Okay?
Okay.
Can I erase?
Over 18.
Sure, can I erase this one?
Yeah, you're fine.
Okay. Oh, what fun. This one's fun because what we've got are a couple of things going on. First of all, as I look at all of those fractions, I have to decide what I need to exclude. And so the denominators can't be 0. So in terms of denominators being 0, if x plus 4 equals 0, that would tell me x cannot equal -4. I'm going to cheat and go to the next easier one, x plus 1. If that equals 0, that gives me x cannot equal -1. And then the one that's a little bit more involved, 3x squared minus 14x minus 49. If I look at that equaling 0, let's say 3x squared is 3x and x. 49 can be 49 and 1 or 7 and 7. And I'm thinking if I do 7 and 7, it's negative 49, so my signs have to be different. So I'm thinking if this is a positive 7 and this is a negative 7, when I FOIL it out, I'd have minus 21x plus 7x, which would give me that negative 14x in the middle. So that's factored correctly. And so when I set those equal to 0, I get that x cannot equal 7. And when I set that other one equal to 0, because the real estate on the page is a little bit pricey, are you all right if I just say that tells me that x cannot equal negative 7/3, setting this factor equal to 0? Now, in order to do this, in order to simplify this one, order of operations, I do what's inside the parentheses first. And are you guys all right? B, we just threw out because there are values that we have to exclude. So now, to simplify it, inside the parentheses, I have 3x plus 7 over x plus 4 times, does everybody remember, in order to multiply, fractions are fun if you factor first. Factor, 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 factor. And so x squared minus x minus 42 would factor into x plus 6, x minus 7, recognizing the fact that 42 is 6 times 7, different signs. And if the 7's negative, it'll give me that negative 1 in the middle. And that denominator we factored into 3x plus 7 times x minus 7. And so when I go through and do that multiplication, the 3x plus 7's cancel each other out. The x minus 7's cancel each other out. And so what's in the parentheses is equal to x plus 6 over x plus 4. And now from that, outside the parentheses, we want to subtract the 3 times x plus 1. And in order to do that subtraction, I need a common denominator. Since they have nothing in common, my common denominator will be the product of the two. And so this first fraction, we've got to multiply by x plus 1 over x plus 1. And the second one, we have to multiply by x plus 4 over x plus 4. I'm doing this sort of ish fast. Am I doing this too fast, or is this making sense to everybody? Does anybody need a slow-mo instant replay?
I need
Yes.
a little bit slower.
Yeah.
Okay. All right. Are you all right with what we're excluding? By
Yeah.
setting-
Yes.
Are you all right in terms of doing the multiplication inside the parentheses? We have to factor that second fraction, and then we can cancel out factors.
Yes.
And so now when I do the subtraction, in order to do the subtraction, I need a common denominator. And because neither denominator factors, my common denominator is the product. That part all right.
The product of what? What
Two
two?
denominators. One denominator is x plus 4, the other denominator is x plus 1. So
What about the other one that you didn't factor yet? Do you not use that one?
which one?
The 3x squared minus 14x minus
Oh, I
49.
factored that already, honey. I factored that up here when I was looking for the domain. And so I recycled that. And then when I multiplied, those factors canceled out.
Okay.
Okay?
Yeah.
All right, better?
Yep.
Okay. And so now the x plus 4 needs the x plus 1. The x plus 1 needs the x plus 4. Whatever I multiply the denominator by, I have to multiply the numerator by. I can be lazy and leave the denominator factored. But I have to multiply the numerator out. The first gives me x squared plus 6x plus 1x plus 6. The second one, when I multiply by the negative 3, gives me minus 3x minus 12. And so when I combine, that gives me x squared plus 4x minus 6 over x plus 4, x plus 1. And I don't think that x squared plus 4x minus 6 is going to factor for me. And so I think we're done. Any better? That one all right?
Yeah.
Okay, then I'm going to erase it. Is it okay if I erase it?
Yeah, you're fine.
You're fine.
Then, anybody want to look at any other homework problems?
19, please.
19? Okay. With this one, first of all, values that I exclude, denominators can't be 0. And so if I look at x plus 4 equals 0, I get that x cannot be negative 4. If I look at x minus 2 equals 0, I get that x cannot equal 2. Inside the parentheses, I have to do each addition or subtraction before I can multiply. So over there where I have 7 minus 42 over x plus 4, I'm going to think of that as 7 over 1. Does that make sense?
Yes.
And so common denominator would be the x plus 4. So I've got to multiply that denominator and numerator by x plus 4. It would help if I wrote the right thing. Sorry about that. So that gives me 7x plus 28 minus 42 over x plus 4, which would give me, heaven help me, 7x minus 14 over x plus 4. Can somebody check my arithmetic? Does that look right? 28 minus 42, I think, is negative 14. In the same way, if I look at 1 over 1 plus 6 over x minus 2, common denominator would be x minus 2. And so when I go through and combine them, that's going to give me x plus 4 over x minus 2. With me so far?
Yeah.
And now that we've got them each simplified, we're going to go through and multiply them. But what should we do first before we multiply? Fractions are fun if you factor first. And whoops, it would help if I wrote this correctly. Typographical errors are the death of me, so watch what you write, watch what you type. That one has a common factor of 7. And since we factored, can we have any fun? Are there any common factors? Is there anything we can cross out?
X plus 4.
Anything else? X minus 2.
Minus 2.
So our final answer is 7. How fun is that?
Over like 5 and 6.
Yes, and then I'm going to kind of draw the line at going over the homework if you don't mind, because I want to make sure we get through a practice test today. All right?
Okay.
Can I clear this or not?
Not yet.
Okay. Ready?
Yeah, you can. Yeah, you're good. Five is multiplication problem.
in order to multiply, well, first of all, we have to worry about values that make the denominators equal to 0. And in order to multiply, we have to factor. So I guess I'm going to cheat a little bit, and this time I'm going to factor before I worry about what makes the denominators equal to 0. And I think you'll see why in a minute. So let's look at that first fraction. How does x squared minus 10x plus 24 factor? I'll do the hard part. For x squared, it's x and x. It's a positive 24, so the signs are the same, both minuses. What numbers multiply to 24 that might possibly give me that 10 in the middle if the signs are the same? Anybody think about anything that multiplies to 24 that can give me that 10 in the middle?
6 and 4.
6 and 4, I like it. Then going sideways, x squared minus 9. Who can factor that for me?
X
What?
plus 3x minus 3.
Beautiful, x plus 3, x minus 3. That x squared minus 36. Who can factor that for me?
X
X
plus
plus
6, x
6.
minus 6.
X plus 6, x minus 6, thank you. And so now x squared minus x minus 12. X squared is going to be x and x because it's a negative 12. My signs are different. One's positive, one's negative. And now I've got to think of numbers that would multiply to 12 and with different signs would add to that negative 1 in the middle. The factors of 12 are 1 and 12. I don't think that'll
4 and 3.
4 and 3. And which should be positive and which should be negative?
Negative 4, positive 3. No.
Yep.
Yeah.
Because when you FOIL, outer would be minus 4,
Oh, yep.
inner would be plus 3x. You got it. Now I'm going to go back because they're all factored now. Did you see that once I've got them factored, it's easier to see what gives me zeros in the denominator? So x cannot equal negative 3, 4, negative 6, or 6. And you see how sometimes factoring before I answer that question makes it a little bit easier to answer it? All right. Now that we've got it factored, is everybody comfortable on their own canceling out the common factors?
Yes, because I got x plus 3 over x plus 6, right?
Beauty. If that's all right, I'm going to clear it. And 6 is similar yet different. 6, when I go through and factor, that gives me in the first numerator, I have a common factor of 4. So that gives me 4 times 2x squared plus 5. X minus 1 does not factor. It's divided by, in there I've got a common factor of 5, and that'll be 2x squared plus 5. And then x plus 1, x minus 1. So right now, looking at that, I know that x cannot equal 1 and x cannot equal negative 1. With me so far? But it's a division, so as a division, I'm going to have to multiply by the reciprocal. So the first one stays the same. The second one becomes x plus 1, x minus 1 over 5 times 2x squared plus 5. And so now I'm worried, can that 2x squared plus 5 equal 0? That would give me 2x squared equals negative 5, or x squared equals negative 5 halves. And at this stage of the game, can I square and get a negative answer? Is there a number I can square to get negatives? No, so I don't have to worry about that denominator equaling 0. And now that it's factor, does everybody see the common factors that can be reduced? Can I stop there? Is that enough setup for you?
I guess that's good, yeah.
Okay. Then let's clear that. And now I'm feeling really mean for the declaration I made at the beginning. Is everybody seeing those done out, or you've got a better handle on this homework?
Mostly, yeah.
Okay.
Only through a practice, but that's what the test is for, so.
That's what that homework's for, and that's what the practice test is for. Do you folks want to go over a practice test together?
Yes, please.
Okay. And before we go over the practice test together, there are a couple of questions that I added to the test that because people had started the practice test already while I added them to the test, I was not able to add them to the practice test. And so I want to make sure that we get through those ones. So are you folks all right if I do those couple first?
Yeah, that's fine.
Okay. So they're the ones at the end. So let's look at, let's thinking. I am sorry, I am looking at what I have, and what I have is not the test for your class, but the test for a totally different class. I'm looking at that problem and I'm thinking, I am in the wrong MyMathLab on this other computer. And so give me a minute. And let me reopen that. I was looking at it, solving an inequality, and I'm like, no, 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 we are not in that. This last question I thought was a complex fraction. And actually, it's kind of similar to one that we looked at in the homework. If I have x over x minus 6 plus 1 over 27 over x squared minus 36 plus 1. Does everybody see that it's a complex fraction?
Yes.
In this question, it's not asking you what to exclude. So we're not going to, is everybody all right if we don't worry about that? And we just worry about simplifying the complex fraction.
Yeah, that's good.
Okay, so the fractions that are showing, what would you say is the least common denominator?
Would be x minus 6 and x plus 6?
I really, really, really like that. Does everybody else in the room really, 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 really like that? Because this denominator factors. So in factored form, that's x over x minus 6 plus 1 over 27 over x plus 6, x minus 6 plus 1. So now we're going to multiply numerator and denominator by that. We'll put it over 1. And in order to do that multiplication, is everybody all right? I have to distribute.
Yes.
And so because this space isn't, oh, you know what? Yeah, I can rewrite that. So that gives me x minus 6, x plus 6 over 1 times x over x minus 6 plus x minus 6, x plus 6 times 1 over x plus 6, x minus 6 times 27 over x plus 6, x minus 6 plus x minus 6 x plus 6 times 1. First one, I can cancel out the x minus 6's. So that leaves me with x squared plus 6x. Over there, if I multiply those out, I get x squared minus 36. Second, the whole denominator cancels, and I'm left with 27. And then when I multiply that out, I get x squared minus 36. So what does that give me? That gives me 2x squared plus 6x minus 36 over x squared minus 9. Does it look better already? What should we do now? Can that be simplified?
Yes.
I think so. I'm not sure though. What should we do to decide if it can be?
Factor it.
Right. Now, when I look at that numerator, when you factor, what do you always look for first?
Common factor.
Right. Is there a common factor between 2, 6, and 36?
Yeah, 2.
So when I take out the 2, that leaves me with x squared plus 3x minus 18. And can that x squared plus 3x minus 18 factor? I think
Yes.
that's x minus 6 and x plus 3. No, it isn't. It's x plus 3 and x minus 6. Right? And how about that denominator?
That would be x minus 3 and x plus 3.
Beautiful. And so now we can,
So you can factor out the denominator after you have, like after you've go ahead.
yeah, whenever you're simplifying, whenever you're reducing, after all is said and done, factor, numerator and denominator.
Oh, okay.
Okay.
That's good to know. That's good to know.
How's that one look? Then there's a multiplication, and I know there's a multiplication on the problem set, but this one's a little bit different, so I want to make sure that we do an example like this one. I've got x cubed plus 1 over x cubed minus x squared plus x times 12x over negative 96 x minus 96. Oh, that's fun. If I'm multiplying, what should I do first?
Factor or find the common denominator.
No, we don't need a common denominator to multiply. We just need to factor. Only time we need a common denominator is to add or subtract or simplify a complex fraction. And we're going to see next week, we'll also need one to solve an equation with fractions, but we're not there yet. So we just need to factor. And so the reason I chose this one, the reason I added this one to the test was because I wanted to make sure that everybody got one with the sum of cubes. Can you guys remember how to factor the sum of cubes?
That would be a no. That's no one answered.
Someone answered?
No, no one answered. So I doubt anyone knows since no one
Okay.
answered the question.
What you have to remember is if I have a cubed plus b cubed, that factors into a plus b times a squared minus ab plus b squared. If I have a cubed minus b cubed, that factors into a minus b times a squared plus ab plus b squared.
Oh yeah, this looks familiar.
Yeah, you need to know it, which is why I threw one of these on the test. And so this is x cubed, this is 1 cubed, so I get x plus 1. Once I've got that, it's the first one squared minus the product plus the last one squared. Now let's look at that denominator. In that denominator, are there any common factors?
X.
X. And when I divide out the x, I have x. Excuse me. I was so taken aback. X squared minus x plus 1. Is anybody smiling about that? Does anybody notice anything?
Oh,
They have-
oh, you can cancel those out.
Top and bottom.
What is that? And then I have 12x over anything common in the bottom.
Oh, and 96.
What type of 96 do you think
A
we are?
negative 96.
And when I take out a negative 96, I'm left with x plus 1. Notice anything else?
Yeah, and x plus 1.
Anything else?
Um,
The X.
an x?
The x. Yeah. And, okay, does anybody think that 12 goes into 96?
Yeah, 3 times. Not how many
8.
times? 8?
8. And so doesn't this leave me with negative 1/8?
That looked.
Its butt is worse than its bite. Yes, it looks worse than it was.
Yeah, that definitely.
Yes, but make sure you remember that sum and difference of cubes. There's a factoring with a leading coefficient other than 1. Let's factor 10x squared plus 6x minus 4. When you factor, what do you look for first?
Common factor.
Is there a common factor?
2.
Yeah, they're all even numbers, so let's divide by 2. And once I do that, I think that makes my factoring a heck of a lot easier, because now that I've divided by 2, when I look at factoring that trinomial, do you see for 5x squared, the only options I have are 5x and x. And for 2, the only options I have are 1 and 2. And so you just have to carefully place your 1 and your 2 so that you get that 3 in the middle. And so I'm going to stop there, and from there, can everybody finish that one on their own? Wow, it's really pouring outside my window. Can you guys hear the rain?
Yeah, it's crazy.
Yeah. Can I go on to the next one? Leave this one for you guys to finish. Next one's a multiplication problem. And I'm sure everybody knows how to FOIL. But what's different about this one is I'm multiplying a binomial by a trinomial. Can anybody remember how to do that?
You distribute like the x and then the 11. Is that how that works?
You can take x times x squared plus 4x minus 2 minus 11 times x squared plus 4x minus 2. I like it. Now what should we do?
distribute the terms.
Yeah, so that gives me x cubed plus 4x squared minus 2x. And over here, is everybody all right? I'm not just distributing 11, but negative 11. So that gives me minus 11x squared minus 44x plus 22. Am I done yet?
No, you gotta combine.
So when you combine, what do you get?
Well, x cubed. It is
4 minus 11 is
7,
negative 7.
7.
And negative 2 and negative 44 is negative 46. And we're done. You're going to find there's some exponent problems. 2x to the negative 8, y to the 7, z to the negative 2, all being raised to the negative 4th. What's being raised to the negative 4th? The 2, the x, the y, or the z?
They all are.
They all are. So let's take 2 to the negative 4th. Oh, when I raise a power to a power, what do I do to those exponents?
You
I heard it. Multiply. 32. Y to the negative 28. Z to the 8. What should we do to make those exponents non-negative?
put it in a fraction form.
So what goes in the top of the fraction?
1. X to the 32 goes in the top because it's positive, and then z to the 8th goes in the top.
And what goes in the bottom?
The 2 to the negative 4th and y to the negative 28th.
But when we put them in the bottom, it's no longer negative?
Yeah, exactly.
Positive.
Okay, am I done yet? What's 2 to the 4th?
16.
Yep. So we'll replace the 2 to the 4th with the 16, and now we're done. Okay. And I think beyond that, let's look at what's in that problem set. All right? The test has 25 questions.
Is that including like the ones we just went over? Those
Yeah.
ones that you added?
Mhm.
Okay.
And for the test, I believe you have a regular class time, which is 75 minutes. The hardest ones are at the end. All right, hopefully this one isn't a challenge for anybody. Is everybody comfortable evaluating an expression given a number? What should I do?
Substitute the 6 where the x is.
So that becomes 5 plus 4 times 6. So is that 9 times 6? Please yell at me and say no. Don't we need a harder number?
No, you multiply the 4 and the 6 first.
Thank you. Oh my God, you guys are really gonna let me do that? I was waiting for somebody to yell at me. Remember your order of operations, they're always gonna hold true, okay? I think it was a quiz where some people definitely forgot their order of operations. Make sure you remember that. That one okay?
Yes.
Yeah.
Yeah.
Next. Ew. What the hell is going on here? Oh dear. A football is kicked vertically upward from a height of 3 feet within a height of 3 feet. Who starts kicking at 3 feet? I guess what field goal kickers, it's not on a stand, they drop it, so that might work, right? Okay, so with an initial speed of 55 feet per second, the formula h equals 3 plus 55t minus 16d squared describes the ball's height above the ground, h in feet, t seconds after it was kicked. Use this formula to find the ball's height 2 seconds after it was kicked. Wow, that's wordy. What part is important that I need to pull out of that question?
The 2 seconds and then the formula.
T equals 2 and the formula is h equals 3 plus 55t minus 16t squared. And so now what do I do?
You just plug in the 2 seconds at 2 for t and then solve it. Or, yeah.
And when I do that simplifying, what do I always have to remember? Order of operations?
Parentheses first.
Right. 2 squared is
4.
4. This is 16 times 4. So then we have 3 plus 55 times 2 is 110. Minus 16 times 4 is 64. And from there, can everybody finish the arithmetic for me?
Yeah.
Okay. Next. Does everybody know all of their properties? Know your properties. Is everybody okay if I just look at this question and say know your properties, or do we need to go over it more? Does
Can you just go
anybody-
over them just one more time?
What does the commutative property allow you to do? When you commute, what do you do?
It changed the order of the.
Right. When you commute, you go back and forth, so the commutative property allows you to change the order. So for multiplication, it would be A times B and B times A. For addition, it would be A plus B and B plus A, but the order's changed. So in this problem, is the order changed? I don't think so. They're both 4, 1, 2, 4, 1, 2. So it's not commutative. What's the idea? Inverses for addition add to 0. Identity for addition is 0. Identity for multiplication is 1. So I don't think it's that, or that. For that matter, as I look at that problem, does everybody see that it's all addition?
Yes.
So I don't think it's going to be any of the multiplication problems. So what does the associative property do? Doesn't the associative property keep them in the same order and regroup, move the parentheses? So that one's the associative property. Process of elimination, all right for everybody with that one. Better?
Yeah.
Simplify. Does anybody want to tell me what to do with this one?
You could just start by just distributing the 9 and -1.
So that gives me 18y minus 63 minus 6y minus 9. Are we all in agreement distributing the 9 and the -1? Am I done?
No, you need to combine like terms.
So what does that give me?
I have 12y. I think mine, well,
Minus
negative
70.
71.
72. And we're done. Are we all good with that one?
Yeah.
Hold on, I have to finish writing it.
Okay. Oh, is Sarah continuously getting booted out? That sucks.
That's good, thank you, I'm done.
But this next one? Help, what did we do?
Would we distribute the
Do you
2?
add the exponent?
We add the exponents.
When we raise a power to a power, do we add the exponents or do we multiply them?
Ooh.
Multiply them?
So when you add, you multiply them? No, when you, to a power, you have to multiply them?
When you, yeah, when I multiply, that's when I add the exponents. When I
Oh.
raise power to a power, that's up. I can write. That's when I multiply them. And again, do I want to leave a negative exponent?
No, you have to put it in fractional form, so 1 over x to the 14th.
Beautiful. I'm hearing the same voices all of the time. People who are being quiet, are you paying attention and getting these?
Yeah.
Okay. Then I'm going to clear this one. Uh-oh, what do I do with this one?
You need to subtract the
Then you
exponent.
subtract the exponents, and then you can
Divide by 2.
Divide by 2.
So what is your final answer?
would be 9x squared.
Yeah, that's all. And I just saw it looked like somebody was in the chat. Do I need to open the chat, folks? Can you see the chat?
Sarah asked, do we have the problem set today or the test today?
The problem set is due on Friday. The test is due on Sunday.
Okay.
Okay. Ooh, scientific notation.
Oh, that's easy.
Okay, so I'm gonna, is everybody all right if I just skip the scientific notation?
Yeah.
Okay, there was one more comment and I'm not seeing it. So yikes.
What did it say? She asked, do we have to submit our work for the problem set, like as a
No, problem
no.
set is, you don't have to submit your work for that. Test you do. Problem set, I'm not gonna go through and give partial credit. You can do the problem set over and over and over and over and over and over again until you get 100 on it. You've got infinite do-overs on the problem set. And so honestly, because the more you do it, the better you'll do on the test. I'm not gonna go back and look at the problem set for partial credit.
Okay.
Okay?
Yep, thank you.
All right, so let's see, what do we have here? The square root of 320x squared. Anybody else thinking the square root of 320 times the square root of x squared? I'll do the hard part. What's the square root of x squared?
X.
Yeah.
X.
Now, what do you want to do with that 320? Can anybody think of a number that goes into 320 evenly?
16.
How many times?
40.
Oh, I don't think it's 40.
Sorry, 20.
Yeah, I like 20 better. I'm writing it because you told me to, and I'm like, wait. 4 times 6 is 64. And can we do anything more? Well, 16 is a perfect square, so I like that one. How about 20? Can we do anything with 20?
Make it 4 and 5.
Uh-huh.
And then the 4 can get turned into a 2.
Yeah. So we're going to think of that as the square root of 16, the square root of 4, the square root of 5. The square root of 16 is
4.
the square root of 4 is
2.
2. The x is out already. Can I take the square root of 5? No.
No.
The final answer is 8x radical 5. That one all right?
Yeah. So we're on number 9 now?
Yep.
I must have missed one.
Oh dear. I think we skipped over one and said it was the scientific notation we skipped over.
Oh, okay.
Everybody told me it was too easy. Ikes, what do I do to rationalize the denominator?
Do you multiply the top and the bottom by radical 13?
Oh, I like it. That sounds like a cool thing to do. Why the heck would I do that though? On the top, 1 times radical 13 is radical 13. On the bottom, radical 13 times radical 13 is?
It's 1, because they can't say, oh no, it's 13.
It's 13. And now I'm done because I don't have a radical left in the denominator anymore. How fun is that?
Lots of fun.
I think so too. God, math is such fun. Can I clear it?
Yeah. Yeah, you can clear it.
Is everybody all right combining like terms adding? In the interest of time, can we skip over this one?
Yeah.
Yeah. Cool.
Everybody comfortable multiplying?
Yes.
Yeah.
Oh, this one's weird. Can I just take everything inside those parentheses and raise them to the second power?
Yes.
If there's subtraction inside, I
Oh,
think
no.
we need to, yeah. I think if there's subtraction inside, I think I need to take that thing and multiply it by itself. And does everybody remember? I guess if you want to, there's a shortcut, but I would probably just multiply these out. Can I stop there, or do you guys need more detail on this one?
Can you multiply it out? So I didn't know how to do it
Are
exactly.
you a boxer, a foiler, or a distributor?
Distributor, usually.
Okay, so I'm going to take x to the 6th y times x, or y to the 7th, times x to the 6th, y to the 7th, minus 5. Then I'm going to take minus 5 times x to the 6th, y to the 7th, minus 5. So that's going to give me x to the 12th, y to the 14th, minus 5, x to the 6th, y to the 7th, minus 5, x to the 6th, y to the 7th, plus 25. And
Yes.
those like terms combine to minus 10, x to the 6th, y to the 7th. So final answer is something crazy like x to the 12th, y to the 14th, minus 10x to the 6th, y to the 7th plus 25. Okie dokie.
Yeah, I got it.
Can you leave that up for a second?
Sure.
Okay, thank you.
Okay. Next one's factoring. We've done a lot of factoring already today, so in the interest of time, I'm going to skip this one.
So no,
This one's factoring too. Is everybody all right with this one? Says it's the difference of two squares. So you got to figure out what do you square to get 196.
can you go over that one for me?
It says difference of two squares, right?
Yeah.
Yeah, so we've got 81x squared minus 196y squared plus minus, what do I square to get 81?
9 and 9.
And what do I square to get 196? If you're not sure, take the square root.
14.
14 and 14. Beautiful. And you can get that from your calculator, right? Taking the square root.
Yeah, thank you.
You don't recognize it?
Yeah, I recognize it. I have it, Mike.
Okay. I think we've done some division already. Oh, who hates division? You're hurting its feelings. I just want to, oh no. These must be set up so that they are, some of them are paired. I know there's one on the test that has a binomial denominator. So I'm going to blow those off for a minute and make sure we do one like, what if I ask you to simplify something like 12 over 3 plus the square root of 2.
You can't have that in the bottom, so you have to multiply that by the numerator and the denominator. So it's
What are
going
you
to be
going to multiply them by?
the 3 plus y radical 2.
Almost.
Was it? No, is it the opposite? So it's going to be 3 minus.
It's the conjugate. In the numerator, I'll do the hard part. Actually, that's the easy part. 36 minus 12 radical 2. In the denominator, do you remember it becomes the first one squared minus the second one squared? So my final answer is 36 minus 12 radical 2 over 7. Again, please make sure you do the problem set more than once because there are pooled questions. And so some questions are paired up. And so each time you do it, it might look a tiny bit different.
Okay. That should help though too, to help us get more practice with different numbers.
Right.
Okay.
So what do you think? Can you guys do this test?
Yeah, definitely.
Hey, I really thought we'd have time to start working at the next section, but my watch is not saying otherwise. So in the interest of time, I think this is where we're going. Does anybody have